And is it going to focus? No. Yes. Very slowly. Okay, I'm just going to have to believe that it's going to work. So, and we start this. So we're recording there, we're recording on the little camera, everything is good. And so today we're going to be talking about easy, well maybe easy stuff, not, okay, familiar stuff. So I think in previous courses in 2110, you've done breadth first and depth first traversals, right? So you know how to do a breadth first and depth. Did you do topological sorts and strongly connected components? Oh, you did topological. Oh, okay. So this should be easy. In that case, some of this is going to be a review. So today we're going to be doing, well, DFS, BFS, and Dijkstra's. And for the DFS, so the example of BFS is mainly going to be Dijkstra's, and DFS is going to be topological sort. And yes, I did start that. And strongly connected components. I'm not sure if strongly connected should have a hyphen. So, yeah, probably it should be strongly connected, but I'm not sure about this. Okay, so you know what a depth first, so depth first traversal, depth first search of a graph, breadth first traversal, breadth first search. I'm also, please remind me if I jump straight to Dijkstra's algorithm, I also want to talk about things like BFS comes up a lot in AI because you're doing sort of state space exploration. So for example, if you want to do that thing where you have a cabbage and a goat and a wolf and you want to get them across, and you have these states and you can transition between certain states and you explore the state space, the minimum number of steps, the minimum number of times you need to go back and forth across the river in your boat is you find that by sort of finding the shortest path between the state where everything is on the one side of the river and the state where everything is on the other side of the river, and you usually do that with BFS. The same thing. I'll probably put this on the assignment, the thing where you have like two jugs and they have certain size and you want to measure out an amount of water that's a different size. You do that with BFS. So okay, I'm not going to say, you need to know that in a DFS and a BF, so in particular a DFS, you have your graph and you start at some vertex and you're doing an exploration, and it can be a directed graph, right? So in a directed graph, you're only allowed to go across the edges in one direction. And whenever you visit, whenever you first arrive at a node, then that you have a clock, and every time you do something, the clock ticks. And when you arrive at a node, you say, okay, that's its discovery time or its start time or whatever. And then the last time you visit the node and be like, yeah, okay, I'm never coming back here again, that is its finish time, okay? So start time is when you first visit and finish time is when you last visit, okay? And that's important. So visited flag is a little, because you also in the book, in the CLRS, there's this thing about like, oh, you color the nodes before you visit them, they're white, and after you visit them, they're black, and when you're still in the process of, you haven't reached the finish, you're between the start time and the finish time, they're like gray or something like that. So that's just like you have a marker that says I've been here. But the start time is like when you first arrived, and the finish time is when you last arrived. And these are important in these two algorithms. Let's just do, so because we're going to break this down into, because I'm just going to check it's recording. Seems to be. Doesn't seem super focused, but so what was I going to say? I forgot what, it can't be important. Okay, so first we're going to start with topological sort. Now the example from the book, do we want to just copy it from the book, or should we do it ourselves? I think it's harder for me to, so it's somebody getting dressed in the morning, okay? And so you have things like socks, shoes, shirts, underwear, okay, so to make this interesting, vest, hat, tie. I think they also have, what have I got? Shirt, okay. What else do I wear? What else do they have? Oh, jacket, they have jacket. Oh, pants, right, this is important. Belt, okay. Belt, shirt, tie, jacket, socks, shoes, watch. Okay. Now, let's say, so let's think about the dependencies. You have to put your socks on before your shoes. Let me just make sure that, yeah, they have the arrows going in this direction. You have to put your shirt on before your jacket. You also have to put your shirt on, oh, and you have to put your jacket on. I don't know this kind of thing because I don't wear a jacket or a tie, but they say that you have to put your jacket on before you put your tie on. You also have to put your tie on, your shirt on before you put your tie on, but this is implied because of transitivity. So vest comes before shirt. Do they say anything? For some reason, they think you have to put your belt on before your jacket. Not sure why. So your underwear has to go before your pants have to go before your belt. I personally find it, they think your shirt has to go on before your belt. Why, I'm not sure. Socks, so your shoes, yeah, okay, so your underwear has to go on before your shoes. Your pants have to go on before your shoes. Oh. Okay, maybe I should just do this the way they have it. Okay, so underwear has to go on before pants. Underwear has to go on. Pants has to go on before shoes. Okay, fine. Watch, they don't care. So socks and shoes, shoes, yeah, tie, jacket. No, wait. Tie has to go on before jacket. Okay. You can tell I don't know. Okay. Hats, they actually don't have a hat, so it's a bit different. I'm not violating copyright. Okay, so this algorithm is to do a topological sort. So a topological sort is you're seeing if there are any cycles. If there's a cycle, it's a catch-22. You have to put your X on before your Y, but you have to put your Y on before your Z, and you have to put your Z on before your X. Right? So a few years ago, I was teaching this in Chile, and my example was if you're trying to get a residency permit in Chile, you have to have an address, but before you can get an address, you need this. Before you can get this, you have to have a residency permit. Yeah. So. The idea, so if there's a cycle, this algorithm is going to find it and return and say that you cannot topologically sort this graph. Otherwise, it's going to find a way of laying out these vertices such that all the dependencies go to the right. Okay? So that way you're going to say, okay, then the first thing I'm going to put on is this, then the next thing. Now, there can be several topological sorts because, for example, it doesn't matter when you put your watch on. It doesn't matter if you put your socks on before your shirt or your shirt on before your socks, okay? So there are lots of different topological orders. It just has to return one topological order. So the algorithm, which, yeah, I was actually going to look up, but then I thought, it's probably too hard to find. And it's probably a sort of a bit too linear, right? But yeah, prerequisite courses, you could do that. It'd be like, okay, you have to have this before you have that, you have to have this. It's also, I also have to have faith that Dow hasn't created a cycle. So, I don't think they have, but you never know. Okay, so let's start somewhere. Okay, so you pick a vertex. Now, initially, you don't, is this used for networks? I'm not sure. I could probably come up with a way you could use it for networks, but I don't know if it actually is. Probably. I mean, topological sort, it's databases, dependencies, dependency graphs in code. You have like this module depends on this module. Basically, if you're figuring out sort of procedures where something depends on something else, then you have this. Okay, so what do we want to start? So pick some vertex, and don't pick like a vertex. So let's pick shirt, okay? Now shirt is not going to be project management, yeah. So shirt is probably not going to be the first thing we need because if you look, you have to put your vest on before your shirt. I don't think they have a vest in the oh, I mean vest like an under shirt. I don't mean like a suit, the vest. In which case you have to put that on after your shirt. Okay, this is undershirt. First time I taught this, I actually managed to mess it up and convince my students I didn't know how to dress myself. So then the next week I actually wore a suit and tie and everything. Okay, so let's say we start with shirt. So, ooh, that's not very good. What happened to my red marker? Okay. So the start time of shirt is 1. Okay? Is that visible? Maybe we can do it in black. There, okay. So the start time of shirt is 1. Now, we go from shirt and we look around from shirt and we say, where can we go? We can go to jacket. So I think maybe they call it discovery. So, jacket, the start time of jacket is 2. And then you say, okay, well, can I go anywhere from jacket? No, so the time for a jacket is 3. You come back, you can't go anywhere else from shirt, so it's 4. So what do you know now? Well, you know that shirt has to come before jacket. So what you're going to do is, as you, let me think, I think you put these in order when you, is it finished? I think it's finished. When you close the vertices, yeah. As you finish, you add it to the list. Yeah. Okay. I have to remember. So now we're going to pick another one. Let's say we're going to pick hat. Okay. So this is 5, and closing finish time is 6. So we say, okay, well, that didn't really get us anywhere. But we finished it, we put it back in the list. Oh, right, it has to be, yes, of course it has to be finish time. It couldn't be start time. Okay, so let's see what else we could do. Let's do pants. So we go to pants, 7. So pants, we can go to belt, right? So this is 8. And now from belt we can go to jacket. We've already been to jacket, so we don't want to go back. So we can't go anywhere else, so it's finish time is 9, so we say, okay, belt. Incidentally, it goes to jacket. And then we come back, and from pants we say, oh, is there anywhere else we can go? Oh, we can go to shoes. So shoes, the discovery time is 10. Can we go anywhere? No. Finish time is 11. We go back to pants. We can't go, and we add shoes to here. And we don't add any arrows. And we go back to pants, and finish time is 12. So pants, it says pants goes to shoes, pants go to belt, pants don't go anywhere else. Okay. So now we're going to move up and go to that. Okay, so does somebody else want to pick another item of clothing that we haven't visited yet? What's something exciting? There isn't really anything exciting. Okay, underwear 13, but we can go to pants, but we've been there. We can go to shoes, but we've been there. So closing time is 14. Underwear goes to pants, underwear goes to shoes. And where else? We can go to socks. 15, we can go to shoes, but we've been there. Can't go anywhere else. 16, so socks. Shoes. This, I said to it always moves to the right. I haven't got enough board space. I should have done it along the bottom here. And finally, tie, not finally, okay, 17, we can't go anywhere, 18, we can't go anywhere we haven't been, so oops. Okay, so this is what happens when you don't copy the example in the book. I should have put an arrow between shirt and tie. Okay. Oopsie. So let's pretend we did. If I had done that, then then here when we went to shirt, we would have found shirt, jacket, shirt, tie. And so it would have been shirt, jacket, tie, shirt. But rather than correct all of the numbers, we're just going to forget about wearing a tie today. So, okay, what's left? Watch. 16, 17, 18. Okay, 17, 18. Okay, so watch. Oh, and hat is already in there. Okay, so the order is watch. So you put your watch on first. Okay, I guess you could. Then you put your socks on, then you put your underwear on, then you put your pants on. This seems to work. Then you put your shoes on, then you put your belt on. It's like, okay, fine, it's working so far. Then you put your hat on, then you put your shirt. I couldn't put my shirt on because my shirts are always t-shirts. I realized that this can be problematic. A few weeks ago, I fell and sprained my elbow and couldn't lift my arm. And I had to really dig through my stuff to find a shirt that isn't a t-shirt. But I do have some. So this is actually consistent with my wardrobe. So if you have a button-up shirt, you can put your hat on first. Then you put your shirt on, then you put the jacket on. Okay, so it works as long as we forget the tie because we didn't put the arrow on from. I could have just copied the graph, but okay, so why does it work? It works in this example. Why does it work in general? This should be ending soon. Why does it work in general? Well, first of all, if there is a cycle, this algorithm is going to find the cycle, right? Because if you have a cycle, so right, you're marking, as somebody said, you're looking at vertices you visited, and if you ever start wandering around and you find an arrow pointing to a vertex that that's had a start time but doesn't have a finish time yet, then you have a cycle, right? Because if you've got a cycle and you pick, at some point you're going to choose or arrive at a vertex in the cycle, it's going to get a start time, S1, and then you're going to say, okay, this is going to get a start time S2, S3, S4, S5, and then you're going to get back here and it started but it's not finished yet. If it started and finished, that's okay, because it means you chose it, you arrived at it earlier and you're done. So it's not an ancestor, right? So a cycle is sort of, if you're imagining the tree, it's not you're not getting a link back to somebody, to one of your ancestors in the tree, because it's finished already. So this is when, for example, we were looking at jacket. When we got to belt, we looked at jacket, it was already done, okay? So it's not an ancestor. The problem is when it has a start time but doesn't have a finish time yet, that means you visit it and you've got a loop. So if there is a cycle, you're going to detect it. And the algorithm is going to say, no, it doesn't work. Okay, so now suppose that there are no cycles. So you're going to start, when you order these things by finish time, you start with some vertex. And then you're going to explore, and your DFS